Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. Uh, today, today, what we are going to do is class 10 subject physics. Topic of today's lecture is 11.8, which is on page number 31. If you open your page 10 class book, page number 31, you will find this topic 11.8 ultrasound. We are going to study today this topic ultrasound, and we will do today MCQs. Chapter number 11 we are doing, that is sound, related to sound. So this is the end. This is the last topic of this chapter, and this is 11.8 ultrasound. I repeat, this topic is on page number 31 of your physics 10th class book, physics book. If you open 10th class physics book, page number 31, you will find this topic, ultrasound. Okay, this we already doing. Chapter number 11 we are doing, and chapter number 11 is related to sound. Today's topic is ultrasound. Before moving to this topic, I will give you a brief review what we did last time. Last time we studied about importance of acoustic and audible frequency range. You know, audible frequency range of human being lies between 20 hertz and 20,000 hertz, as I have already told you. So the human being cannot hear less than 20. If the frequencies are less than 20 hertz, they cannot hear, and they cannot hear if the frequencies are more than 20,000 hertz, or human being, human beings ears cannot detect the frequency less than 20 hertz or more than 20,000 hertz. So human beings audible frequency range is 20 hertz to 20,000 hertz. This is the human being's audible frequency range. So I told you the definition of audible frequency range. The range of the frequency which a human ear can hear is called the audible frequency range, and the range is 20 hertz to 20,000 hertz, or we can say 20 hertz to 20 kilohertz. Okay, as the young people can hear frequency range of frequency, audible frequency, they can hear the frequency 20,000 hertz. But if they go uh, older and older, they cannot. The older people can hear 15,000 hertz. As I told you in my last lecture, they can hear the frequency range of 15,000 hertz, because by the age their ears can be defective, so they cannot hear like the young people can. So audible frequency range is 20,000 hertz. Young people can hear the frequency range is 20,000 hertz, but older people will not hear the frequency range of 20,000 hertz, but their hearing will be lost, and they can hear up to frequency 1,000 hertz. Okay, because it is depending upon their ears condition. So I told you the range of the frequency which a human ear human ear can hear is called audible frequency range. But today's topic we are going to discuss 11.8 topic, and the topic is ultrasound. Our topic is ultrasound, that is on page number 31. You can see at the bottom, you will see the page number 31. Sound, I read the definition of ultrasound, or we simply say ultrasonic waves, sound of frequency higher than 20,000 hertz, which are inaudible to the normal human ear are called ultrasound or ultrasonic waves. Again, I repeat, sound of frequency sound of frequency higher than 20,000 hertz. You know, the audible frequency range of human being is 20 hertz to 20,000 hertz. You know this. But if the frequency is more than 20,000 hertz, if the sound of frequency higher than 20,000 hertz, which a human being cannot hear, so that is called ultrasound or simply we say ultrasonic wave. If they ask you to define ultrasonic waves, you will write the same definition. But if they ask you the definition of ultrasound, you will write the same definition. A sound of frequency higher than 20,000 hertz, which are inaudible. Inaudible means not hear, cannot hear. Inaudible to the normal ear, human ears are called ultrasound. Ultrasound. This is the definition of ultrasound. Okay. So now we are going to discuss uses of ultrasound. What are the uses of ultrasound? The first use of ultrasound is in dead bullets. Dead bullets. These are the uses of ultrasound. Okay, I will discuss one by one with you the uses of ultrasound waves. The sound waves of frequency more than 20,000 hertz, which is inaudible for the human ears, that is called ultrasound or ultrasonic waves. So now we are going to discuss uses of ultrasound. You can see this figure as well. Before doing this, I will read this for you as well. Bats can hear frequency up to 1,20,000 hertz. Okay, which means they can hear the frequencies of 1,20,000 hertz. Other animals cannot hear such higher pitched sound. Like mice can hear frequency up to 1,00,000 hertz. Dogs up to 35,000 hertz. So human ears can hear up to frequency range of 20,000 hertz, but the frequency of dogs can hear 35,000 hertz, right? And the cats up to 25,000 hertz. Human ears sound only up to 20,000 hertz, but children can usually hear higher frequency sound than the adults. So these are the different frequency range for the different animals. For example, bat can hear frequency up to 1,20,000 hertz. It means bats' ears are more sensitive to the sense. They can uh, they can hear the frequencies up to 1,20,000 hertz. It means their hearing is more than human beings, and human beings can only hear the sound of frequencies 20,000 hertz. But the frequency of mouse is 1,00,000 hertz, which means their hearing capability is more than human beings, and dog's hearing capacity is 35,000 hertz. So it means it has more capacity than human ears. So 25,000 hertz, cats can hear 25,000 hertz, but human ears can only hear frequency 20,000 hertz. But children's hearing is more than the adults. It's very much clear. In this figure, you can see 11.3 doctors are taking ultrasound test of the patient with an ultrasound machine. They are using this is a machine. They have a monitor in front of them. So they are examining the organs of the patient. So doctors are taking ultrasound test of the patient with the ultrasound machine. This is the ultrasound machine. Okay. Next example, you will see ultrasonic, or we say ultrasonic waves or ultrasound. Ultrasonic is used to measure the depth of the water by echo method. We have discussed echo when we discussed in the last topic, we discussed about echo. When we clap in front of the quiet buildings, tall building, you will hear the sound after some time. This is called echo. Same principle will be involved in the ultrasonic waves. So we can, with the help of ultrasonic waves, we can measure the depth of the seabed. Because you cannot depth with the meter rule or meter tape. You need to use some types of waves which have more frequencies to measure the depth of the seabeds. Okay, so this is a ship. This is the boat or ship which is on the surface of water. They use the ultrasonic waves to detect the depth of the seabed. So this is another use how we measure the depth of the seabed by using the ultrasound or ultrasonic waves. Okay, so these are the uses we will discuss one by one now. Ultrasonic waves carry more energy and higher frequency than audible sound waves. Audible sound range for the human being is 20,000 hertz, but ultrasonic waves have frequencies more than 20,000 hertz. That's why they are saying ultrasonic or ultrasound. So higher frequency and audible sound waves, you know this. Therefore, according to the wave equation, we have discussed this equation in the last chapter. V is equal to F lambda. In 10th chapter, we discussed V is equal to F lambda. Okay, there is a relation between velocity and the wavelength and frequency. So V is the speed, F is the frequency, and lambda is the wavelength. We discussed when we read the chapter number 10. The wavelength of ultrasonic wave is very small and is very useful for detecting very small. Wavelength means the distance between crest and trough is coming quickly. Okay, so wavelength, ultrasonic wave, the wavelength of ultrasonic wave is very small, but the frequency is very high. You should remember this very. You should be very much clear between what is wavelength and what is frequency. When the wavelength is less, it means frequency will be more. When the wavelength is more, then the frequency less. Okay. So in this case, wavelength, in case of ultrasonic waves, since wavelength is small, so it means there is a one-one relation between wavelength and frequency, a reciprocal relation between wavelength and frequency. If the wavelength is more, frequency will be frequency will be less, and if the wavelength is more, frequency will be less. If the wavelength is small, then the frequency will be more. Okay. In this case, ultrasonic waves, since wavelength is small, and then frequency will be higher. So ultrasonic wave is very small and is very useful for detecting very small objects. That's why their frequency is more. That's why they are used for detecting very small objects. Okay, I will discuss one by one. Ultrasonic waves carry more energy and higher frequency. Already told you, they have the higher frequencies, mean wavelength is small, their lambda is small, but frequency will be more. They have higher frequency. So due to the characteristic of the higher frequency, so they are used for detecting small objects. Second point is which is in bullet. I read this point. Second point, bullet point. Ultrasonic waves are utilized in medical and technical fields. They are used in both medical and technical. Medical means the doctor use these ultrasonic waves to do the uh, ultrasound of different organs in the bodies. They test the organ, kidney, heart, uh, or different organs in the body, the condition of the different organs of the body with the help of ultrasonic waves. Okay, technical mean technical mean the people working in the seas, ocean ships. They use this to detect the cracks in the machines, or that's why they are saying ultrasonic waves or simply ultrasounds utilized in medical and technical. Third point, sorry, in third bullet, in medical field, how they use in medical field, ultrasonic waves are used to diagnose and treat different diseases, different diseases. These ultrasound waves are used, or ultrasonic waves are used in diagnose which organ is bad or which organ is a good condition. What they do, what the what how the medical field, the doctor use ultrasonic waves. Look, for diagnose different diseases, ultrasonic waves are made to enter the human body through transmission. How the doctor transmit how the doctor transmit the ultrasonic waves into the body of the patient. what they do, they use a transmitter to enter the ultrasonic waves. Okay? These waves are reflected differently by different organs, tissues, or tumors. The reflected waves are then amplified to form an image of the internal organ of the body. So if the there is a healthy organ and one is a bad organ, right? So for example, the doctor want to test the kidney, the condition of the kidney. So we know there is a healthy kidneys and there are the bad kidneys. So when they pass the ultrasonic waves with the help of the transmitter in the body of the patient, then these waves will be collide with the defective part and come back. These waves will come back to the and they with the help of receiver they can and on the monitor screen they can see the condition of the organs. Whether it is a good organ or whether it is a bad organ. Okay, whether it is a good or bad organ. With the help of these ultrasonic and they will pass the ultrasonic waves into the body of the human being or into the defective organs, and then these waves will ultrasonic waves will come back and give the information that this is the good condition or bad condition. The doctor will compare the bad organ and with the good one, so they can easily detect which one is bad and which one is good. Okay. Fourth, powerful ultrasound is now being used to remove blood clots formed in arteries. Arteries are the vessels which carry the blood from to all part of the body. From the heart to the other part of the body, they carry the blood to the all the. There are the two types of vessels. One is arteries and one is a vein. Arteries are those vessels which carry the blood to all part of the body, but but the veins are the vessels which carry the blood, the deoxygenated blood back to the heart for the purification for the cleaning purpose, right? So if there is a blood clot, if there is a blood clot in the arteries, the blood cannot flow through very with fluency with very flow. So in order to remove the blood clot, the doctor use ultrasonic waves to remove the blood clot formed in the artery. The fourth one. Ultrasound can also be used to get the pictures of thyroid gland for diagnosis purposes. For example, you have a problem in thyroid gland. Where are the thyroid gland located? Thyroid glands are located in the throat. They are located in the throat. So how the doctors do? They get the picture of the thyroid glands in order to diagnose the problem. What is the problem in the thyroid gland? In order to diagnose the thyroid gland, the condition of thyroid gland, they pass the ultrasound. Next. Ultrasound is used to locate underwater depth or is used for locating objects lying deep on the ocean floor. Okay, this is the technical. Before we are talking about medical fields, how the doctor use the condition of the thyroid gland and how a doctor use the condition of the different organs in the body through the ultrasound waves. But that was the medical field. That was related to medical field. As I have already told you, ultrasonic waves are utilized in medical and technical field. Now I'm talking about technical field. So this one, two, three, four, five, 6 point is regarding to the technical field. Okay, ultrasound is used to locate underwater depth. So if I want to find out the depth of the underwater, I cannot measure with the help of any instrument like meter rule, 1 meter, because these are these instruments are used only for detecting small distance. But if I because the depth of the seas or ocean is more very great or very more, so we cannot detect with the help of we cannot measure the depth of the depth of seabed with the help of these instruments. So we use the ultrasonic waves or ultrasounds to measure the depth of the seabed, or if there is the what is inside the oceans, we can also locate the objects where the object is. If we want to locate the objects underneath the oceans, we can also use this technique. This technique is called this technique is called sonar. Sonar means sound navigation ranging. S means sound, uh, N means navigation, and R means range. Sound navigation ranging sonar. This technique is in order to find the locate the underwater depth or locating objects lying in the oceans. We use the technique that is called sonar, sound navigation ranging. The sound waves are sent from a transmitter. So in this case, in sonar technique, sound navigation ranging, we have a transmitter and a receiver. Okay, two things are sound waves are sent through a transmitter and they receive by the receiver. So there are the two things involved in sonar techniques. One is transmitter and one is receiver. Transmitter which transmits the signal, which transmit the sound wave, or receiver which reflects the sound wave back. The sound waves are sent from a transmitter and receiver collects the reflected sound. The time lapse is calculated knowing the speed of the sound in water, knowing the speed of the sound in water. Okay, मैं ऊंचा बोलता हूँ. Yes, the sound waves are sent from a transmitter. The sound waves are sent from the transmitter and the receiver collects the reflected sound. The time lapse is calculated knowing the speed of the sound in water, the distance of the object from the ocean surface. So I told you that using this technique, using the sonar technique, which there is a transmitter and the receiver. Transmitter send the sound, and these sound when collide with the depth, the depth of the object underneath the ocean, and they will come back by echo method. They will come back, and we will calculate how much time it requires to reach back to us. So this means we can calculate the depth of the seabed, or we can also calculate what is the object uh, underneath the ocean. Okay. So next thing is sonar, which is now I'm on page number 32. Uh, Sonar ranging is used to see the shape and the size of the object. Sonar means sound navigation ranging technique is also used to shape what kind of shape of the object which is underneath the depth of the ocean or sea, or what size of this object. So um, the military, air, the navy actually use these techniques because there is a ship for the enemies to be down in the seabed, so they are on the surface of the water. But by this technique, by using the sonar technique, they can find what size of the object and what shape of the object is. So they can easily detect the which shape is of enemy ship or which shape is of friendly ship, or they can also run. In order to detect the cracks in the cracks that appear in the interior moving parts of the high-speed heavy machine, such as turbines, engine, or this is the fifth, sixth use of and for talking about cracks now. If there is a cracks in the machinery, you can also detect the cracks where the cracks is, because it is very difficult to find the crack if the machine is too big. If the machine is too big, you cannot easily detect the crack where the crack is located. But with the help of ultrasound and ultrasonic waves, you can easily detect the cracks. So again, the transmitter and receiver. The transmitter will send the sound navigation with the help of sound navigation ranging techniques. We send the sound to the transmitter, and by echo method, this will come back to the receiver, and we can by the time lapse we can calculate the where the crack is locating the actual. getting a problem. So this is the problem where we are getting a problem. So cracks appear in the interior of the moving parts of high-speed heavy machines such as turbines, engines of the ships, and the airplanes respectively. These cracks are not visible from outside, but they can be very dangerous. Such cracks are detected by ultrasound. A powerful beam of ultrasound is used to pass through these defective parts. While passing, these waves are reflected by the surface of these cracks and flaws. The comparison of ultrasonic waves reflected from cracks and from the surface of these parts can give clue of the existence of the cracks. But if you don't have this technique, what will happen? Since the thing is very big, the ship is very big, the turbine is very big, the engine is very big. So this will be takes ages to find out where the crack is actually located. But with the help of these techniques, we can find the cracks quickly, or we can diagnose the crack quickly, or we send the team, the engineering team, to remove this crack because these cracks afterward they will be dangerous. Germs and bacteria, and the last point, germs and bacteria in liquids can also be destroyed by using high intensity ultrasonic waves. With the help of these ultrasonic waves, we can also kill the germs and bacteria in liquids. So with the help of ultrasound waves, we can also kill the, because they are of more higher frequency, so we can kill the germs and bacteria in the liquids with the help of ultrasound or ultrasonic waves. So these are, students, these are the end of the chapter, and we have done this ultrasound. We discussed about today's 11.8 topic, ultrasound, and first of all we discussed the definition of ultrasound, and then when we discuss the uses of ultrasound, where we actually use. These are basically using both medical and technical fields. Ultrasonic waves or ultrasound waves are basically used in both medical and technical fields. I hope you understand this. So now I'm moving towards MCQs, multiple choice questions, which are on page number 33. If you open your textbook, uh, page number 10th class textbook, page number 33, you will find multiple choice questions. So I have already done for you, I marked these MCQs first for you. So, which I read the MCQs for first MCQ first, which is example of the longitudinal waves. Which is the example of the longitudinal wave? The choice is one A, sound waves, B is light waves, and C is radio waves, and D is water waves. My right answer is A, which is sound waves. Now I'm moving towards the next one. How does sound travel from its source to your ears? One, A is by changes in air pressure, by vibration in wires of strings, by electromagnetic waves, or by infrared waves. Though my answer is A choice, by changing in air pressure is the right one. The third MCQ is which form of energy is sound. The choice A is electrical, B is mechanical, third is thermal, and D is chemical. So my second choice, which is B, mechanical, is the right answer. Again, which form of energy is sound? A choice is electrical, B choice is mechanical, C choice is thermal, and D choice is chemical. So my right answer is B1, which is mechanical. The fourth MCQ is of astronaut in space needs to communicate with each other by radio links because they communicated with one another. How they communicate, astronauts in space, by one another? The first choice is sound waves travel very slowly in space. Sound waves travel very fast in space. Third is sound waves cannot travel in space. Okay, so you know the sound waves require some medium to travel, as we have discussed. When as long as the air is and medium is there, as long as the air is present, so sound can easily travel. If there is no air, the sound cannot travel. It means the right answer is C. Sound waves cannot travel in space. C is the right answer for MCQ number 4. Now I'm moving towards fifth. The loudness of sound is most closely related to its A choice is frequency, B choice is period, C choice is wavelength, and D is amplitude. So my right answer is D1. The loudness of sound is most closely related to its uh, amplitude. Amplitude is the right one. Fifth answer, amplitude D part is the right answer of MCQ number 5. For normal person, audible frequency range, a sound wave lies between six MCQs now. For a normal person, audible frequency range for sound wave lies between, as I have told you, audible frequency range is 20 hertz for a human being is 20 hertz to 20 kilohertz, or we will say 20,000 hertz. Okay, so B choice is the right one. When the last MCQ is when the frequency of sound wave is increased, which of the following will decrease? Okay, the first is one is wavelength, second one is period, or third one is amplitude. So I repeat, when the frequency of a sound wave is increased, which of the following will decrease? Well, first choice is wavelength, second is period, and third one is amplitude. So my C answer is 1 and 2, wavelength and P. Wavelength and P, C choice is wave. 1 and 2 is the right answer. 1 and 2 only is the right answer. So when the frequency of the sound wave increase, whenever we increase the sound wave frequency, which of the thing will be decreased? Wavelength and period will be decreased. Okay, so this is the end of the MCQ. Students, in the next class, we will solve the problems because today we have ended the chapter number 11 sound. This is ended. Now we will solve the numericals in our next lecture. I hope you all understand. Just a quick review what we did today. So in today's topic, first of all, I gave you the brief review what is the audible frequency range, which is the audible frequency range for human ear. Human being is 20 hertz to 20,000 hertz. Human ears cannot hear less than 20 hertz frequency or more than 20,000 hertz. This means their range lies between 20 hertz to 20,000 hertz. So younger people have the range 20,000. They can hear the frequency sound of frequency 20,000 hertz, but if they go get older and older, their sound frequency range goes on decreasing. So older people cannot hear the sound of 50. They can hear the sound of 50, the range of sound of frequency range 50,000 hertz. So audible frequency range is which a human ear can hear. The human ear can detect only 20 hertz to 20,000 hertz frequency of 20 hertz to 20,000 hertz. Now we discussed about 1.8 ultrasound, which is the topic of today's lecture. Sound of frequency higher than 20,000 hertz, which are inaudible. Inaudible, which our human ears cannot detect, which our human ears cannot listen or hear. Two normal human ears are called ultrasound or infrasound. Then we discussed the different uh, uses of ultrasound. We saw that how we use ultrasound to detect. They are used in both medical and technical fields. First of all, how the doctors use these ultrasound waves to detect the defective organs of the body, and how they detect the condition of the thyroid gland, which is in our throat. And then we discussed about how the technical, this is also used in technical fields. So how they use in technical fields in order to measure the depth of the seabeds. This ultrasound wave pass through the transmitter and they reflect back by echo method and received by the receiver. So then we can, with the help of this, we can detect the cracks in the machinery, in the big machines, where there is a very difficult to diagnose the crack actually, and it will take ages to find the cracks. But with the help of this technique, we can find the cracks easily. Where the cracks are actually located, then we send our engineering teams to fix the cracks. Then they are also used to kill the germs and bacteria when the ultrasound waves are passed. So this is the end of ultrasound today's topic. I hope students understand. If you have still questions regarding this topic which we covered today, you can feel free to ask this question. So now I'm waiting for you to